Hey, what's up, guys? This is John here again. So this time, let's take a look at this problem, number 1737. Change minimum characters to satisfy one of three conditions. This one got a lot of downvotes because of the ambiguous description. So you're given like two strings, A and B, right, and only consists of lower case letters. And in one operations, you can change any characters in A or B to any lower case letters. And your goal is to satisfy one of the three conditions here. So the first one is that every letter in A is strictly less than every letter in B. And second one is similarly, but instead it's a B is strictly every letter in B is strictly less than every letter in A. And the third one is the both A and B consist of only one distinct letter. So I think the third one is the confusing part. But actually, so when it comes to the coding or the logic, the last one is the easiest one. And instead the first two is kind of tricky. So I think the first two is kind of obvious, right? So which means that so so the first two can be translated to the smallest after some operations. The For example, the first one, right? The biggest letter in A is smaller than the smallest letter in B. That's the first two, either the first one or two the conditions. And the last one is that both A and B consist of only one distinct letters, which means that we can do some operations to make uh, all the letters in A to be the same letter, right? It could be, let's say if we have AA, ABA, so we can make A to all three A's, right? 3A, 3B, 3C, 3D. Doesn't really matter as long as they're all the same. They are the all same letters. It's fine. Same thing for B, right? So let's talk about the third one since it's the easiest one. For the third one, I think this is kind of greedy. Obviously, if we want to use the minimum operations to make A to be the same to be the distinct one distinct letters, of course we will just keep the letters that have the biggest frequency, right? And then we'll just replace the other letters to be the same as the letter with the most frequencies, right? Same thing for for B, and that's how we're gonna satisfy the third condition. And the tricky part is for the first two conditions. So given like a two strings, how can we know what's the minimum operations so that let's only consider the first one, right? So all the letters in A is smaller than all the letters in B. Mm, Actually, so the solution is like you can think of it like a brute force solution with a little bit of optimization because since we only have like 26 letters, so our approach is like this. So first, we'll count the each letters in both A and B strings. So for example, let's say in in string A, we have A, B, and D letters. So in string A, right? So we have let's say we have two A's, we have one B, and we have three D. And in string B, similarly, we have three A, uh, one B, and five D. I mean, it doesn't have to be the same letters. I'm just using this one as an example. So the way we're trying to get the minimum operations to satisfy the first condition is that we try each of the letters from A to Z. So for each of the letters, what we're trying to accomplish that, let's say we have a letter B here, or let's try with the letter A here. So with the letter A, what I'm trying to do is I'm going to use the letter A as a threshold. It means that, I'm going to make some operations so that, all the letters in string A is either equal or smaller than the current threshold. In this case, it's going to be I'm going to make some operations so that, all the letters in A it's either equal or smaller than A. And similarly for B, right? And all the letters in B is greater than A, right? Since we need to satisfy the strictly less than condition here, right? And then we try A, we try B, we try C, we try D until the Y. So the reason we cannot try Z is because, uh, if we try Z, right, the Z here, anyway, so either way, B cannot be strictly greater than Z. That's why we cannot try Z. We can only try up to Y. And and in terms of the implementations, so if you watch this one closely, let's say when we're at A here, right? When we're at A here, so what's gonna be the total operations to make to satisfy the first conditions? It's gonna be a 4, right? Because, we have B and D, which is smaller, which is greater than A. That's why, for A, right, the operations in A will be 4. Okay. And how about the operations in B? So the operations in B is like we need 3, right? We need 3 operations to make B greater than A, which is exactly the count of 3 here. And then if we move to B here, the next one is B, right? So if we move to B, then what's gonna be the number here? So operations for A to make all the numbers either equal or smaller than B. It's gonna be 3, right? So this is gonna be 4 minus 1, right? So actually, so at the beginning we have what? We have 6. So it's gonna be so at the beginning the total is 6. So 6 minus 2 and then minus 1. And same thing for the B here. Instead we have 0. We have 0 plus 3 and then plus 1. That's that's the uh, that's the operations we need to make for B, right? So that, all the letters in B is strictly greater than the letters B here, which is we have basically we have to change its A and B, right, to what? To some bigger number, which is we can always change it. We can always change it to Z. Now, so then we can come up with some solution here, right? Basically, we're gradually removing the letters, right? The count from the 6, so that, we can make sure the all the letters in A is either is not greater than the current threshold. And then on the other side, we're gradually adding the count for the count of B, so that, all to get the operations that all the letters in B is greater than the threshold. So yeah, I think that's going to be our solutions, which means that we have to do a count for A and B. So let's do it. And so let's see, we have I'm going to create like some elements here, right? So we have A here and B, length of B, and then I'm going to have like count A of counter of A, right? And then we will count B counter B. So and I'm going to define like helper functions. Maybe I'll just call it a change. Mm, yeah, maybe I'll just call it a change. So we have I'll pass in the count A and count B basically. So we have let's say we'll count A and count B. And this one basically will give us the minimum operations so that the the string A will strictly less than the string B, right? Each letter. So basically the first conditions. So like I said, we're going to define like system max size here. And then for operations of A, right? So we have a op A, right? Because we start with what? We start with the sum of the hmm, we start with the total numbers, which is going to be the C uh, A dot values, right? It's going to be the total numbers in this A here, right? In the count A. So here I'm passing in the counter, right, to here, so that it help me to calculate that. And then up B, right, gonna be starting from 0. And then for C in this English letters, right, A, B, C, D, right, until Y. I mean, you can I'm I'm just hard coding uh this 25 English letters, or you can use like 0 to 20, 20, 25 to 25 or to 20, 24 to do the for loop. But if that's the case, you have to basically you have to translate each of the characters into its corresponding integer, right? But I'm just using the letter itself as a key. So and then we have op A, right? And then for the op A, so the current operations for A to make the all the letters in A, which is smaller, not greater than the current C, is it's going to be the CA dot C, right? So and similar for the B, going to be the plus dot, right? CB dot C, and the answer will be the minimum of the answer dot operation A plus operation B, and then we just return the answer. So and then we can have like the answer 1 is the condition 1, right? So basically we change from the count A and count B. So for answer 2 here, we just copy and paste. Instead, we reverse this A and B to get the condition B. And for the condition 3 here, we just need to do a NA max count A dot values, right? So that's the minimum operations to make A distinct, only one distinct letters, and then we plus the same thing for B, right? Max of the count B dot values, right? And then in the end, we return the minimum among all those kind of answers. Yeah, and that's it. Yeah. So I mean, the time complexity, so obviously it's like it's all of n, right? So since we only have like single for loop, uh, and the space complexity is also O of the space complexity actually is O of one because we only have a counter, right? And the counter is like the element is up to 26, right? Since we only have like 26 English letters, that's why it's O one. Uh, yeah, so for this kind of problem, the I think the tricky part is this helper functions, the how can we get the minimum operations to strictly to make this the first satisfy the first condition. And our solution is that we just brute force. We try each of the letters as as a threshold so that we can move all the letters in in the string A to be either equal or smaller than the threshold characters, and we move we change all the letters in in the string B to be greater than the current threshold, and then we try every single letters, and then we get the minimum among those all. Okay, and here we are basically using a counter to help us to calculate this one in O1 time. If we don't do this don't do it in this way, this one's gonna be a O(n) time because for each letters, let's say for A, B, C, and D, we have to loop through the entire A and the entire B to get the minimum operations. But since we are trying the numbers, sorry, since we're trying the letters from the smallest to the biggest, you know, and when we are at like letter C here, in order to make all the letters uh, smaller than C, right? We only need to change all the letters in A who is greater than C, right, to be the current operations, which is the accumulation of this one, right? Because we're starting from the from everything, and then we're removing the ones that is smaller than the current one gradually, and then the remaining part is the operations we need to make. Similarly for B, right? To make everything in B is greater than the current threshold here. Basically, we just need to uh, right. So we have A and B, right? Let's say, for example, we have A and B. So to make everything greater than C, so of course, everything has also needs to be either greater than A and B. That's why, we can just safely accumulate the 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 count for A and B. So this is like more like a dynamic, little similar to the dynamic programming. But that's basically we're gradually building up the minimum operations within O1 time. That's a bit trick, a little trick here. Yep, I think that's it for this problem. And thank you for watching the video, guys. Stay tuned. See you guys soon. Bye bye.